Hi, this is problem 14 from the AMC 12A. Alice refuses to sit next to either Bob or Carla, and Derek refuses to sit next to Eric. How many ways are there for the five of them to sit in a row of 5 chairs under these conditions? Okay, so it looks like we have that Alice doesn't want to sit next to Bob, A doesn't want to sit next to C, and D doesn't want to sit next to E. So it looks like we'll have to break this up into cases. And in general, for counting problems, when you want to break up into cases, you want to break up by the most restrictive condition first. So in this case, Alice is the more restrictive condition because she doesn't want to sit next to either B or C. So let's break this up into cases based upon where Alice sits. And let's see how that works. So in the first case, we'll put Alice to the left. Move her one over. Sit her in the middle. Over one. And seat it to the right. So that's 5 cases, and that seems a bit messy, but what I notice is that these are symmetric cases, and these are symmetric constraints. So the counting that we do for the second case should match the counting we do for the fourth case, and the first should match the counting for the fifth case. So we really only have to do 3 cases here. So let's see how we can do that. So I always like to look at the easiest case first just to kind of get started. Looks like the middle case is probably the easiest because if A is in the middle and B and C don't want to sit next to A, that means B and C have to be at the ends, or we could swap their positions, and that forces D and E to be as shown, or their conditions could be swapped. So that leads to 2 times 2, 4 possible arrangements for Alice being in the middle. Let's do the next one up. We have A as the second position. B and C can't be next to A, so B and C have to be in the fourth and fifth locations, or their positions could be swapped. And D and E are in positions 1 and 3, or their positions can be swapped. So again, that leads to 2 times 2, 4 possible cases. For A on the left, that looks a bit more complicated. So now B and C have to be in positions 3, 4, and 5, but let's see now. We'll have to break this up into subcases. So let's look at the subcase where A is on the left, B and C are scrunched up in the left portion of these last 3 remaining seats. D and E have to be placed as shown, but again, these can be swapped. So again, we have 2 times 2, 4 possible cases. Let's try the case where B and C are in positions 3 and 5. That forces D and E to be in these locations. Again, we can swap these to find 2 times 2, 4 possible cases there. And finally, if we place B and C at the end, that forces D and E to be together, and that's not allowed, so that's 0 for this final subcase. So let's add them all up. We have 4 plus 2 times 4 plus 8 times 2, 4 plus 8 plus 16, 28 for choice C.